All right, let's jump right in. Imagine you've got this digital detective team that can sift through absolute mountains of crime data, right? Connecting dots that a human analyst might just completely miss. That's the core idea behind a system called CrimeScope, and we're going to break down exactly how it pulls it off.
But before we get into the how, let's talk about the why. It all comes down to this one massive challenge. See, in today's world, clues aren't just lying around at a crime scene anymore. Nope, they're buried deep inside spreadsheets, news articles, and endless case files. So the real question is, how on earth do you solve a crime when the clues are just hidden in this overwhelming ocean of data? And that leads us straight to something you could call the analyst's dilemma. It's a bit of a paradox, really. The very people whose job it is to spot patterns and stop future crimes, they're the ones who are completely drowning in the sheer volume and, frankly, the complexity of all this information they're supposed to be using. So let's break that down a bit, because this is where it gets really interesting. Just think about it for a sec. If one police report calls something a theft, but another one calls a similar incident larceny, how do you even begin to connect those two? The data's all over the place. You got neat CSV files over here, and then messy, unstructured news articles over there. There's no magic button you can press to just find all the recurring patterns. And on top of all that, every analyst might have their own unique, kind of fragmented way of doing things. It's slow, it's manual, and it's a system that's just screaming for a smarter approach. So, okay, how do you solve a problem like that? Well, the answer isn't just to do the old manual stuff a little bit faster. No, this calls for a complete shift in thinking, a whole new paradigm, one that's built around a team of AI detectives. And this is the real conceptual leap. The idea isn't to build one giant, all-knowing AI model, the kind that becomes this incredibly complex, mysterious black box where you don't really know how it's making decisions. Instead, the question becomes, what if we built a coordinated team of specialized AI agents? It's kind of cool because it actually mimics how real detective teams work, right? Everyone has their own specific job, and they pass their findings along to the next expert in line. So this whole concept has a proper name. It's called a multi-agent system. And the most important part of that definition is that phrase, beyond the capabilities of any single agent. It is all about teamwork. You might have one agent that's a genius at reading files, and another that's an expert in geography. On their own, they're useful, but working together, that's when they can crack a really complex case. And listen, this isn't just some abstract, theoretical idea. We're actually looking at a real-world example called CrimeScope. This was a Capstone project that came out of an intensive program run by Kaggle and Google, and it was designed to show exactly how this multi-agent approach can work in the real world. Okay, so now for the fun part. Let's pop the hood and take a look inside the CrimeScope system. Honestly, the best way to picture it is like an AI assembly line for generating intelligence. And this diagram just perfectly illustrates that whole assembly line concept. You can see it right there, a clear, linear pipeline with 6 specialized agents. All the raw, messy data goes in at one end, and each agent does its one specific job before handing off the now refined information to the next agent in a chain. It's clean, it's super organized, and importantly, it's completely auditable. So let's do a quick walkthrough of this assembly line, step by step. First up, you've got the data intake agent. Its only job is to suck in all that raw data from different places, CSVs, news articles, you name it. Then it hands off to the crime classifier agent, which is kind of like a meticulous librarian. It takes every single incident and neatly slaps a label on it: theft, cybercrime, fraud. Next in line is the pattern miner agent. This one's the real detective, digging through all the descriptions to find recurring keywords and clues. Once it has those, the Hotspot Detector Agent gets to work. Think of it as putting pins on a map, grouping incidents into geographic clusters. Then you have the Risk Factor Agent, which is like the lead investigator connecting all the dots, linking the what with the where and the how. And finally, at the very end of the line, the Report Writer Agent takes all of that complex analysis and turns it into a simple, easy-to-read intelligence report that a human can actually use. Okay, so after this whole AI team does its thing, what's the end result? What do you actually get out of it? Well, this is where we go from just crunching data to producing genuine, valuable insight. The system spits out concrete, actionable intelligence that looks something like this. See, this isn't just a laundry list of crimes. It's a synthesized insight. It tells an analyst exactly what is happening, in this case, cybercrime. It tells them where it's happening, Zone 4, and it even tells them how it's happening by pointing to specific keywords like phishing or server breach. This is the kind of stuff a human analyst can take and act on right away.
So you might be wondering, why go through all the trouble of building a team of AIs? Why not just build one giant, super smart model? Well, it all comes down to the power of teamwork, even for artificial intelligence. And this really gets to the heart of the two different philosophies. On one hand, you've got the single, monolithic model, which can be this incredibly complex and tangled black box. It's hard to debug and a nightmare to update. But on the other hand, you have the multi-agent system. It's modular, which means each agent is its own separate piece. You can upgrade the classifier without breaking the hotspot detector. It's auditable. You can actually look at the output from each step to see where something went wrong. And it's extensible. Let's say you want to add a new agent that predicts future crime trends. You can just plug it right into the pipeline. It's just a much more flexible, transparent, and manageable way to build this kind of AI. And all of this leaves us with one last really fascinating question to think about. I mean, crime analysis is just one use case, right? If these specialized AI teams can work together to solve a puzzle this complex, what else could they do? What's next? Could we see them diagnosing rare diseases, uncovering incredibly sophisticated financial fraud, maybe even optimizing our entire global supply chain? The potential here, it's just enormous.